हे एवरीवन, आई एम सत्येंद्र चंदेल फ्रॉम नमो स्टडीज़। आज हम आपको मिलाने जा रहे हैं नमो की एक न्यू फैकल्टी से जो अपनी ग्रेजुएशन कंप्लीट कर चुके हैं और इसी के साथ ही एसएससी और रेलवे के एग्जाम भी क्रैक कर चुके हैं। ये हमारे ऑफलाइन टीचर हैं जिनका टीचिंग में 2 साल का एक्सपीरियंस है और ये आपके लिए रेगुलर डाउट सॉल्व कराते रहेंगे।
Thanks Namo for introducing me. I am Sanjeev Kumar and today we are going to discuss a topic which is laws of motion. Saksham from 9th class of Delhi Public School has asked this doubt in the group. So we are going to discuss this topic. See, there was a scientist named Isaac Newton. He gave 3 laws of motion. Those 3 laws explains the motion of everything that moves in this universe, whether it is a planet, whether it is a bird. So to explain that motion of any object, he gave 3 laws. So what are those 3 laws? We are going to discuss those 3 laws here. So the first law of motion, let me just write it for you. First law of motion. This law is also known as the law of inertia. So I'll just write in bracket law of inertia. So what does the first law of motion states? It states that if there is an object at rest or if there is an object moving, then it remains in that state unless it is acted upon by an external force. So let me just write the statement of the motion of the law for you people, that an object remains at rest or motion state unless acted upon by an external force. Acted upon by an external force. This is the statement of this law. Now there are some examples of this law of motion. So I'll just give a brief example for you people. So you have to imagine something. Imagine you are sitting in a bus and you are going to your grandmother's home. Okay, now see, there is a bus moving here. Okay, so this bus is moving in this direction with the velocity v. Now you are sitting inside of this bus. Now what happens that there is a cow in front of bus. So the driver applies brake suddenly. It applies suddenly. So what happens that you jerk forward in the bus. Why it happens? Because your body was in the motion, in the forward motion. But when the brakes were applied, bus was stopped by the brakes, but you couldn't stop because your body was in the forward motion, and that's why your body jerks forward. So that jerking forward of the body happens due to the law of inertia. Okay, I hope it makes sense to you. Now we are going to discuss the second law. I'll just write the second law for you people. Okay, so this also goes this one. So second law of motion. What does the second law of motion states? Second law of motion states that the rate of change of momentum of a body is proportional to the force applied on it. Let me just write this statement for you people so that you can understand better. The rate of change of momentum, the rate of change of momentum of a body is directly proportional to the force applied on it. Directly proportional to the force applied on it. To the force applied on it. Now there is also a mathematical expression of this law of motion. We can also write that, which is that F is equals to ma. This is the mathematical expression of the second law of motion. We can also derive this formula. Okay, so I want you to write this down in your copy, and then we are going to derive this formula. I hope that you have written it down. Now we'll derive the second law of motion formula. So see, we know that the momentum of a body can be written as m, which is mass into velocity. From further on, we'll write it as m and we'll write it as v. Now try to imagine that there is a ball. Okay, now what happens, that someone kicks this ball. Okay, so someone applies F force on it. Initially it has velocity u. Okay, this goes forward with the velocity u and it has mass m. In the final state it has mass m, because mass doesn't change with the application of the force, and the velocity is v. This is v. So momentum here can be written as mu, initial momentum. We'll just denote the momentum as p. So we can write p initial is mu and p final, m here is the mass and v here is the velocity of this ball. So it can be written as mv. Now the difference between the final momentum and the initial momentum can be written as difference of final and initial. Difference of pf minus pi, it is mv minus mu. Okay, now if you see, to derive that formula we have to divide it by the t. Why t? Because when we divide something by t, its rate comes out. So we can write that rate of change of momentum it is mv minus u upon t, and this t's value will be equal to the time difference between this state and this state. This t, it's not the distance, okay, it's the time when this state was achieved and this state was in the beginning. So we can write it as t, it is u. Okay, remember this is u, this is not a. Some guys may get confused in it. So this whole thing can be written as a. Why a? Because we know that a is equals to v minus u upon t. So we can write it as ma. So it comes out as F is equals to ma. So the rate of change of momentum, which is force, is equals to ma. So that was the derivation of the second formula. Now there is also a third law of motion. It's a pretty basic law because there is nothing much to explain here. Okay. So the third law of motion is What does it states? It states that for every action there is equal and opposite reaction. For every action there is equal and opposite reaction. What are the action and reaction here? Action and reaction are the forces. Okay, you have to pay attention to the two words here, which is equal and opposite. For every action there is equal, okay, the forces must be equal and opposite in direction. So if someone is applying F force to a block, to a wooden block, so if someone is applying F force to it, then this M block, sorry, this wooden block of mass M, this is mass, okay, it's a wooden block, it's a block made of wood. So if someone applies F force on this wooden block, then this wooden block applies F force in this direction. So this wooden block applies F force in this direction, in the backward direction. Since this force in this direction and this direction we have taken as the positive direction, so this force must be negative. Now what happens now, some students gets confused in this negative sign, so don't get confused. See, this negative sign only represents the direction. It doesn't mean that the force is negative. There can't be negative forces. Forces are always positive, but since this force was applied in the backward direction, hence we have taken it as negative. So this third law of the motion can be written as in the mathematical expression something like F AB is equals to minus F BA. But are these AB and BA? I'll explain. F is the force which A applies on B, and minus F is the force which B applies on A. Okay, so and this minus n represents the direction of the force, the backward direction, or we can say if someone is applying in this direction, then the second force will be in this direction. So this minus force represents the direction. So yeah, I hope these three laws make sense to you, and if you have like this, then please give us a thumbs up.